Saket from B section AIML. My topic in this subject is conditional probability and the law of total probability. I have given information on introduction, what is conditional probability, how to calculate conditional probability, what is the law of total probability, how to apply the law of total probability, and in the last, conclusion. So now let us know the introduction. Welcome to our presentation on conditional probability and the law of total probability. In this presentation, we will introduce you to the concept of conditional probability and the law of total probability, and explain why it is important to understand them. By the end of this presentation, you will have a clear understanding of what conditional probability is, how to calculate it, what the law of total probability is, and how to apply it in real world scenarios. We hope that this presentation will be both informative and engaging, and we look forward to sharing this knowledge with you. Now let us know what is conditional probability. Conditional probability is the probability of an event occurring given that another event has already occurred. It is calculated by dividing the probability of both events occurring by the probability of the first event occurring, given that another event has already occurred. It is calculated by dividing both probability of both events occurring by the probability of the first event occurring. For example, if the probability of an event A occurring is 0.3 and the probability of event B occurring given that event A has occurred is 0.2, then the conditional probability of event B given event A is P of B by A. Probability of event B by event A is equals to 0.2 by 0.3 is equals to 0.67 according to the given data. To be better understanding this concept, let's consider an example. Suppose you are playing a card game and you draw 2 cards from a deck of 52 cards. What is the probability of the drawing a king on the second draw given that the first card draws a queen was a queen? The answer can be found using conditional probability, which takes into account the fact that one card has already been drawn. We will explore more examples throughout this presentation. Here I have given a beautiful diagram to understand the conditional probability more efficiently. Probability of A by B is equals to probability of A intersection B by probability of B. If probability of A by B is equals to probability of A and the probability of B by A is equals to probability of B, then events A and B are independent. So take time and understand the diagram. Now we will know how to calculate the conditional probability. Calculating conditional probability involves using the formula probability of A by B is equals to probability of A and B by probability of B, where probability of A and B is the probability of both events A and B occurring, and the probability of B is the probability of event B occurring. It is important to note that when calculating conditional probability, the sample space is reduced to only those outcomes that satisfy event B. Let's continue with our previous example of drawing cards. Suppose you draw cards from a deck of 52 cards without replacement. What is the probability of drawing a king on the second draw given that the first card drawn was a queen? We can use the formula for conditional probability to calculate this as probability of king by queen is equals to probability of king and queen by probability of queen, where probability of king and queen is the probability of drawing both a king and a queen, and probability of queen is the probability of drawing a queen on the first draw. We will walk through more examples to help you understand this concept. What is the law of total probability? Probability. The law of total probability is a fundamental concept in probability theory that states that the probability of an event can be found by considering all possible ways in which that event can occur. In other words, if we have a set of mutually exclusive events that cover the entire sample space, then the probability of any event can be found by summing the probabilities of all the possible ways in which that event can occur. To better understand this concept, let's consider an example. Suppose you are a doctor trying to diagnose a patient with a rare disease. There are three possible tests you can perform, each with a different accuracy rate. And you know the prevalence of the disease in the population. The law of total probability can help you calculate the probability of the patient having the disease given the results of the tests. We will explore more examples throughout this presentation. Now look at the diagram carefully. I have given this diagram to understand the concept more efficiently. This might be helpful to understand this concept. Now let us know how to apply the law of total probability. To apply the law of total probability, we need to identify a set of mutually exclusive events that cover the entire sample space. We then calculate the probability of each event and use the probabilities to find the probability of any other event. This concept is often used in real world scenarios such as decision making, risk analysis, and statistical inference. Let's continue with our previous example of diagnosing a patient with a rare disease. We can use the law of probability to calculate the probability of the patient having the disease. Given the result of the test, we can walk through more examples to help you understand how to apply this concept in practice. Now let's get into the conclusion. To apply the law of total probability, we need to identify a set of mutually exclusive events that cover the entire sample space. We then calculate the probability of each event and use these probabilities to find the probability of any other event. This concept is often used in real world scenarios such as decision making, risk analysis, and statistical interference. Let's continue with our previous example of diagnosing patient with a rare disease. We can use the law of total probability to calculate the probability of the patient having the disease. Given the result of the tests, we will walk through more examples to help you understand how to apply this concept in practice. Hope you understood the concept which I have given in this PPT. Thank you so much.